Hello there, this is the solutions video for section 3.3. We're on page 176. The first three I wrote down the answers already on the board. I want to bring the graphs into view here. So for number one, we are decreasing, remember go left to right, from negative infinity to 3, and then increasing from 3 to infinity. Remember, in the interval, you're giving the x values. For number 3, going left to right, we are increasing from negative infinity to negative 2, and then decreasing from negative 2 to positive 2, and then increasing again from 2 to infinity. And then on number 5, left to right, increasing from negative infinity to 0, and then decreasing from 0 to positive infinity. So if you made any mistakes on that, here are the answers. Go ahead and write those down and look at the graphs again. Remember, going left to right. Going up is increasing, going down is decreasing. Okay, so let's go through our first derivative test, which are the rest of the problems. And some of these problems are kind of tedious, all right, especially towards the end of the assignment. So our first one is f of x, or number 7, excuse me, f of x is equal to negative 2x squared plus 4x plus 3. All right, you want to double check that. So first thing you always do is take the derivative. It's minus 4x plus 4. Set that equal to 0. All right, and when x is 1, that'd be negative 4 plus 4. When x is 1, then this function, this derivative is 0. So our critical point is x is equal to 1. So I like to draw the sine line right next to where I'm going to plug in, which is the derivative. Don't accidentally draw it next to the original function f of x, or you'll plug into the wrong thing. Let's put our critical point right here at 1. To the left of 1, I'm going to pick 0. So plug 0 in, and you'd have a positive 4. So it's positive. To the right of 1, I'm going to pick, let's say, 2. That'd be negative 8. Plus 4, that'd be negative. So we are increasing until we get to 1, and then decreasing after that. So we have a max right here. So we have a max at the point 1, and we plug 1 back into the original equation. That'd be negative 2 plus 4, that's 2, plus 3 is 5. For a minimum, we have none. I want you to go ahead and write that down. Okay, we don't have a place where the derivative goes from negative to positive, so we have none. Increasing, we are increasing from negative infinity to 1. Decreasing from 1 to infinity. All right, so pretty much I'm going to erase the board every time after these. Some of them, this one didn't take up too much room, but some of them really do. So there you go with number 7. Let's move on to number 11. All right, number 11, we have f of x is equal to 2x cubed plus 3x squared minus 12x. All right, we're going to take the derivative. That'd be 6x squared. Don't forget the squared. 6x squared plus 6x minus 12. Gonna factor out a 6 here, and so we would have x squared plus x, right? And then if I factor out a sig minus 2. Set that equal to 0. We're trying to find the critical points. Let's see if we can factor this. So we have an x, x. How about plus 2 minus 1? So our critical points are negative 2. That would make this parenthesis 0 and positive 1. And I want to write them from negative to positive, from least to most. And this is where I want to plug in my numbers. So I'm going to put it right by the factored version. That's the easiest. Negative infinity, positive infinity, negative 2, 1. Do not put 1 then negative 2, all right? Don't make the mistake some of my students have done in the past, okay? We've got to do it left to right. Okay, to the left of negative 2, I'm going to pick a number that's easy for me in my head. That's negative 10. So if I put negative 10 there, this parenthesis would be negative. This parenthesis would be negative. Negative times negative is positive. What number in between negative 2 and 1? Always pick 0 if you can. 2 would be 0 plus 2 is 2 times negative 1. That's going to be negative. And then greater than 1, let's pick 2. That'd be positive, positive, so positive. Let's draw our arrows, increasing to there, decreasing to there, increasing there. So we have a max at negative 2 and a minimum at 1. So we are increasing from negative infinity to negative 2. Just follow the arrow. And then again we're increasing from 1 to infinity. We're decreasing from negative 2 to 1. We have a maximum at negative 2. The x value is negative 2. And then we're going to plug that negative 2 back into the original equation. 2 times negative 2 cubed plus 3 times negative 2 squared minus 12 times negative 2. If you go through that, you'll get a positive 20. And then we have a minimum at 1. And then that would be 2 plus 3, 5 minus 12. That would be negative 7. And these answers make common sense because 20 is bigger than negative 7. If we had them reversed, then you know that we've made a mistake, because your minimum has to be less than your maximum, right? Okay, that's a good, solid problem. I can see a problem like something like that on the test, right? Where you have to do a little factoring and you have more than one critical point. Okay. All right, 15, we have f of x is x to the 1/3. Now this is almost exactly like an example, okay? So this one I probably shouldn't have picked, but that's okay. The derivative is 1/3 x to the minus 2/3. I'm going to write that as 1 over 3x to the 2/3. We set it equal to 0. It can never be 0, right? Because it's undefined. At x equals 0. But that does make x equals 0 a critical point. It's not only where there are maxes and mins, it's also there are critical points where the function has an asymptote or is undefined. So we have a critical point at x equals 0. I'm going to draw my sign line right next to the easiest place to plug in to the derivative, which in my brain is right in here, 1 over 3x to the 2/3. Our critical point is 0. To the left of 0, I'm just going to pick -1. So -1 to the 2/3 will be +1 because you have to square it. So that's going to be positive. And then 1, if you plug 1 in, also positive. So we are increasing from -infinity to infinity. Sometimes you can't put -infinity to infinity, but there's no asymptote here. We just have, if you were to graph this, we would have a little, at 0, it's vertical there. We are decreasing, never. We don't have a maximum because these arrowheads never come together, right? You don't have you're not going down, it's always going up, so none. And we don't have a minimum. All right, so beautiful. That is it's a nice, quick problem to work when they're like that. Okay, now we're going to get into a little bit more on the tedious side. I think especially maybe number 27, if I'm remembering right. Okay, so number 19. We have f of x is equal to x squared over x squared minus 9. So what we want to do, I think the best move here is just to use the quotient rule. So we'd have the bottom, x squared minus 9, times the derivative of the top, 2x, minus the top, x squared, times the derivative of the bottom, 2x, all over x squared minus 9, all squared. I'm going to go ahead, and this would be 2x times x squared would be 2x cubed minus 18x, and then minus 2x cubed. So it's worth the work over x squared minus 9 all squared. So that would simplify into just minus 18x over x squared minus 9 all squared. Now we have a fraction here, so we want to know, where is the numerator 0? Well, so we have a critical point at x equals 0 because that's the numerator is 0. The denominator also, what numbers make the denominator 0? Well, it's going to be 3 because 3 squared is 9, and also -3. So I'm going to plug in these 3 critical points right next to this because that's kind of easy to do in my head, to look at that. -infinity to infinity. Now don't put 0 first. -3 comes first, then 0, and then 3. All right, to the left of -3, I'm going to pick -10. -18 times -10 would be positive, and then that's going to be positive because you square it, minus 9 squared, positive over a positive. All right. How about -1? That'd be a good one to pick in this interval between -3 and 0. Okay, so that'd be positive, -18 times -1, positive, and then since you're squaring it, the bottom's going to always be positive. Now if I plug in 1, I've got a negative. The bottom's always going to be positive because we're squaring the answer. So that's negative. And then if I put in 5 or 10, negative over a positive, that's negative. So I have something that looks like this, that, and that. We do have a max. The lines come together at 0. So we are increasing. Now we do have an asymptote at -3, vertical asymptote there. And we have a vertical asymptote there. So we can't include -3 and 3. We can't cross that. So we're increasing from -infinity to -3. And also from -3 to 0. But we can't say from -infinity to 0 because when you hit that vertical asymptote, you can't include that in the interval. Then we are decreasing from 0 to 3 and from 3 to infinity. We have a max at the point 0, and then we're going to plug 0 back into the original equation. That's 0 over -9, so 0, 0. And we don't have a minimum. So no minimum. Based on these arrows, you can tell that. All right, so that one was a little bit more work because we had kind of a fancier derivative with the fraction. Okay, so the answer's there. Okay. All right, 21 and 27. 21 doesn't look too bad. So for 21, we have f of x is equal to x cubed minus 6x squared plus 15. Okay, so we're going to take the derivative. 3x squared minus 12x. Set that equal to 0. I would factor out a 3x, and what's left would be x minus 4 equals 0. So our critical points occur at x equals 0, right? Because you plug a 0 in here, that whole thing's going to be 0, and then also 4. And the best place to put your sign line is right next to the easiest place to plug in. So -infinity, infinity, we have a 0 and a 4. Okay, left of 0, I'm going to put in -1. That'd be negative times negative, that's positive. How about a 2? No, 1 would be easier. Between 0 and 4, I'll always pick 1 if you can, so that'd be positive times negative, so negative. And then we can pick 10 if you want to the right of 4, positive times positive, that's positive. So we're increasing, decreasing, increasing. Hey, so we have both a max and a minimum. We're increasing from -infinity to 0 and from 4 to infinity. We are decreasing from 0 to 4. We have a max at the point 0, and if we plug in 0 to the original, it would be 15. And then we have a min at the point 4, and then you plug in 4, 4 cubed 64, minus 6 times 16 plus 15. You know, your calculator's your friend if you want, but it would be -17. And that answer makes sense because 15 is greater than -17. So we don't have, we pass the sanity test. Is my answer sane? And there we go. Beautiful. Good problem. Definitely, you know, this difficulty of problem could be something I picked for the test. Kind of a middle of the road type problem. All right, moving along. 3 left. 27. So 27, we have f of x. X squared minus 2x plus 1 over x plus 1. So this is a candidate for the quotient rule. So we have the bottom, x plus 1 times the derivative of the top, 2x minus 2, minus the top, x squared minus 2x plus 1, times the derivative of the bottom, x plus 1, all over the bottom squared. So looking at this, I do know that I have a critical point at x equals -1, because that makes the bottom 0, right? But I got to figure out the top. And this is a pain in the caboose. But I'm going to go ahead and FOIL all this out. Multiply it all out, combine like terms, and set the top equal to 0. So f prime of x is equal to, that's going to be 2x squared plus 2x minus 2x minus 2. I just FOILed the top. Minus, all right, x cubed oh, I'm sorry. The derivative of the top let's see, the bottom times the derivative of the top minus the top times the derivative of the bottom is just 1. That does make this a little bit easier. So I did FOIL out this over here, but I accidentally rewrote x plus 1 there. So sorry about that. So minus x squared plus 2x minus 1. Combining like terms, let's see, I would have 2x squared on top minus x squared. So 2x squared minus x squared would be x squared. And then 2x minus 2, that goes away. So these two go away. All right, so I got that. Those two go away. And then I would have plus 2x minus 3. Okay, so f prime of x, I'm going to go ahead and factor this. So there's a lot of work on this one to figure out the critical points. Although one of them is easy, right? So we have x, x. And how about plus 3 minus 1? All that's equal to 0. So our critical points occur at, we know -1. So it's going to be -3, right? -1 and 1. So I'm going to draw my sign line here. Negative infinity to positive infinity. And put those critical points in. -3, -1, and 1. All right, to the left of -3, I'm going to pick -10, okay? So the bottom's always going to be positive because you're squaring it. So it's just really about the top. Okay, so let's say -10, that's negative times a negative. That's positive over a positive. How about -2? That'd be positive times a negative. So that's negative. All right, we get to pick 0 in this interval. So that'd be 3 times -1, which is negative. And then let's say 2. That would be positive times positive. So I've got up down, down. Sorry about my messy arrows, up. So I have a max here and a min here. Okay, so I'm smushing this down at the bottom, but I think we can do it. Increasing from negative infinity to negative 3. And also from 1 to infinity. We are decreasing from negative 3 to negative 1. Now don't include, don't go negative 3 to 1 because it's not decreasing at negative 1 because there's an asymptote there. All right, and then from negative 1 to 1. So from negative 1 to 1, it's decreasing. We have a max at the point, negative 3, and I have to plug negative 3 into this original equation up here. When you do that, it'll be negative 8. Just use your old calculator. I tend to try to do all this stuff in my head. And then we have a min at the point 1. 1's a little easier, right? 1 minus 2, negative 1 plus 1. It's going to be 0. All right, so that answer doesn't really make sense because I guess you have a relative max at that point, and then the curve gets bigger. So this is a local max. That's why it's greater than your minimum. Let me check the answer in the back of the book real quick. So let's see. We are on page 176. Sorry about this delay. But number 27. Yeah, looking at the graph there, that does make sense on this one because there's an asymptote. So you have a max to the left of this asymptote. So you got a vertical asymptote. You have a max to the left, and the max is negative 8. And then the graph completely changes to the right of the asymptote. So when you have a situation like that with an asymptote, yes, you can have a max that is less than a min. But that hasn't been true on the previous problems that we've worked. All right, so we've got 2 more to work. Number 29. So 29, we have f of x is equal to x over 2 plus cosine x. So that's the same as 1/2 x. F prime of x would be 1/2, and the derivative of cosine is minus sine x. We're going to set that equal to 0. So our critical points is where does sine x equal 1/2 on the unit circle. So let's get the old unit circle out. All right, and our interval is between 0 and pi. They're not making, if you look at the problem, they're not making us go past that. All right, so where is sine x equal to 1/2? It's equal to 1/2. Remember, it's cosine then sine at pi over 6 and also at 5 pi over 6. So our critical points occur at pi over 6 and 5 pi over 6. So I'm going to draw my sine line. And we would have pi over 6, 5 pi over 6. So to the left of pi over 6, if you look, sine goes down to 0 to the left of pi over 6. Then sine is less than 1/2, so it would be positive. 1/2 minus a smaller number. then between pi over 6 and 5 pi over 6, sine is bigger than 1/2. Okay, so it would be 1/2 minus a bigger number, so it's negative. And then between 5 pi over 6 and pi, then sine is positive. All right, and then that goes all, we're actually, instead of infinity, we're going to 2 pi. So negative infinity, sorry about that. We are going from 0 to 2 pi. All right, and then after that, sine is negative in quadrants 3 and 4, so 1/2 minus negative would be a positive. So it would be all positive from 5 pi over 6 to 2 pi. So we're going up and then down and then up again. So get this out of the way. So 0 to 2 pi. All right, we've got a max and a min. So this one is a lot less tedious, even though it's trig. We're increasing from 0 to pi over 6. Again, it's not negative infinity because they told us. And then also from 5 pi over 6 to 2 pi. We are decreasing from pi over 6 to 5 pi over 6. We have a max that occurs at pi over 6. And when you plug pi over 6, that'd be pi over 6 divided by 2, which is pi over 12, plus the cosine of pi over 6, so that's plus root 3 over 2. You do not have, that's fine. Just leave it like that. Don't make this, that's good. Don't do what the book does. And then 5 pi over 6. Well, I don't know what the book does, actually. I haven't looked at the book. They may turn this into 6 root 3 over 12 and then put it all in one fraction, but it's fine. 5 pi over 6, so that's going to be 5 pi over 12. And then the cosine of 5 pi over 6 would be, let's take a look at that. The cosine of 5 pi over 6 is negative root 3 over 2, isn't it? So minus root 3 over 2. So pretty cool. And we can just leave it like that. Okay, one more to go. What a tedious homework assignment. I wonder who assigned all this homework. Well, hopefully all this homework will make you super ready for the test and you'll just ace the test. So let's take a look at number 56. And if I remember this right, 56 is not really too tough. So 56, we've got a profit equation and our intervals between 0 and 35,000. We want to find where it's increasing or decreasing. So we have P is equal to 2.44x minus, I'm going to rewrite this as 1 over 20,000 times x squared minus 5,000. And our interval is from 0 to 35,000. Okay, so I rewrote that to take the derivative easier. P prime is going to be 2.44 minus 1 over 10,000, right? 2 times 1 over 20,000 would be 2 over 20,000, so that's times x. We're going to set that equal to 0. So we have 2.44 is equal to 1 over 10,000 times x. So x, we would multiply both sides by 10,000, right? Is 24,400, and that is our critical number, our critical point. And I'm going to plug that in right here. 0 35,000. Let's just put a K. And we have 24,400. Okay, to the left of 24,400, I'm just going to pick 1. 2.44 minus 1 over 10,000 times 1 is positive. And then let's pick, I don't know, 30,000. So 30,000 over 10,000 is 3. All right, so 2.44 minus 3 is negative. So we're going down. So it just asked, the problem just asked increasing or decreasing. So we are increasing from 0 to 24,400. And then we are decreasing from 24,400. Our profit is decreasing. So we better stop making them at 24,400. Don't make more. You start to make less money. Okay. Long homework video. I hope you didn't have to watch all of them, but if you did, I hope that helped you, and I will talk to you next lecture.